So today we will see the demonstration of testing of contactors. So here we have L&T make contactor. You can see this is contactor L&T make ML2. So ML2 is the series that L&T manufactures, and here you can see its specification is AC3. You can see over here 32 ampere AC3, 415 volts, 50 hertz. Okay, so it means that the rated current of the contactor is 32 ampere, rated voltage of the contactor is 415 volts, rated frequency is 50 hertz, and type of the contactor is AC3. Okay, and then as far as coil voltage is concerned, the coil voltage is also 415 volt, and here you can see the coil is basically placed here. This is, you can see the terminal A2. This is, it is written here A2, and on this back side here you can have, it is written A1. So between this A1 and A2, in short, the coil is placed in the contactor. So I have connected two wires, these two flexible wires, to A1 and A2. And now for the testing purpose, where I have connected these two wires, I have connected these two wires of coil A1, A2. These are connected to VAC. See this black wire and yellow wire. So this terminals of this coil A1, A2 are connected across the controllable AC supply. Okay, so we know in the testing kit we are getting controllable AC voltage of 500 volt, as well as we are getting controllable DC voltage of 500 volt. Out of that we will use here controllable AC voltage of 500 volt for testing purpose. Now I will open the cover of this contactor, and once I open the cover of the contactor, you can see the internal open view of the contactor, isn't it? And similar diagram, cross-sectional view of this open contactor we have seen in the presentation, or in fact it is there in the write-up. Okay, so what we will do, we will find out its pickup voltage and dropout voltage. For that, the procedure is, first of all, we will switch on the voltage source. We will switch on the voltage source, and then we will gradually increase the voltage. That voltage will be you are able to see over this AC voltmeter, right? And then at one particular voltage, the contact will picks up without humming. So here you can see at present there is a gap between the contacts. So here you can see there is a gap between these are the main contacts. Okay, this is the fixed contact, this is movable contact. So there is a gap. There is a gap between these two contacts. There is a gap between these two contacts. So this is in open condition. So when pickup is reached, these contacts will be attracted. Moving contact will be attracted to the fixed contact. So this will be position where the contactor is in a closed position, and at this instant we will note down the pickup voltage. Okay, and then we will reduce the voltage gradually, and at one particular voltage the contacts will be drop off. So that voltage we will note down. Ready? So I will switch on the supply. So as usual, I will switch on the main supply, ICTP on the table, right? Then I will switch on the 4-pole MCB on the switchgear testing kit. So supply is reached to the kit now. Here you can see supply is reached to the kit. Now I will switch on the voltage source variacs. So I will push the start push button, right? And I will push this AC DC selector switch to AC position, because we want to apply the controllable AC voltage, and we want to measure that with the help of this AC voltmeter, right? So now see, I will gradually increase the voltage. So slowly I will increasing the voltage. You can see this increase in voltage on the voltmeter, which is inbuilt in this kit. Okay, so at one particular voltage you will find that this contactor picks up and the contacts will get closed. So now see, I am gradually increasing the voltage. At present I have applied 115 volts, 120, 130. Still the contacts are in a open position. Okay, so let us see. See now the chattering begins. Now the chattering begins. Here you can see the sound, chattering begins, but still the contacts are not in a closed position. And see, I have kept the contactor in the horizontal position. We were to test it in two positions, horizontal and vertical. Presently I have kept it in the horizontal position. I am taking the pickup and dropout. So see now the vibrations are increased. Now I will get perhaps the pickup. See, the contacts are in open. This voltage is now 230. I have applied. Horizontal position, pick up, I am taking. Still the contacts are not in a closed position. See, the contacts are now totally closed without humming, and the voltage you can note down 255. Okay. Now I will slowly reduce the voltage and take the drop off. Okay. So pick up we got 255 in the horizontal position, and now I will reduce the voltage slowly. I am reducing the voltage slowly. At one particular voltage now the contacts will be drop off. So we have to note down that voltage in the horizontal position. Remember, I am testing it in the horizontal position, this contactor. See, now this voltage is 204. Still the contacts are in a closed position. We have not got the drop off. I am still reducing 186 volt. Still contact in closed position. 178. Yes. Now it is in open position. 169. So I got 169 for the drop off. Okay. So I will now reduce the voltage and make it to 0. Right. So these two values I will note down. Pickup I got at in the horizontal position. I got the pickup. How much? Pickup was 255 in the horizontal position, and drop off I get at how much? 169 volts. Right. So this is how I got the pickup and drop off values when I test it at horizontal position. Okay. Now we will test the contactor, same contactor in the vertical position. Okay. So I will keep this contactor. Now this is the horizontal position. Okay. Now I will keep the contactor in the vertical position. This is called a vertical position, and generally the contactor is installed in the vertical position always. So this is the correct position. Now we will check its pick up and drop out again. So I will gradually increase the voltage. See, I am increasing the voltage. Gradually I am increasing the voltage. Still now the contacts are in open condition. Now applied voltage I am gradually increasing. It is now 90 volts, 120, 130, 140, 160, 200. Still the contacts are in open condition. Now chattering begins. 230. So gradually I am increasing. 242, 250. Now I will get the pickup perhaps. Let us see. See, 270 volt has reached. 280 has reached. Yes, 280. So we got 284, round about 284 or 285, the pickup. Okay. So I will write down the pickup 285 in the vertical position. So 285 volts pickup in the vertical position. Now I will gradually reduce the voltage to note down the drop off. Okay. So I will gradually reduce the voltage. See, now I am reducing the voltage slowly. And now at one particular voltage I will get the drop off. So let us see at what voltage I am getting the drop off. I am testing in the vertical position. L&T make ML2 contactor. Contactor number 1, whose coil voltage is 415 volts. 200. Still the contacts are in a closed condition. Still contacts are in a closed condition. 170, 69, 163. So we got round about 162. The drop off has reached. So I will write down 162 volts. That is the drop off. So you can see that during the testing of this particular ML2 contactor, you can see here this when I test it in the vertical position, I got pick up 285 and drop off I got 162. Whereas when I test it at horizontal position, I got the pickup 255 and I got drop off 169. And these are the specifications of the contactor. ML2 L&T make AC3 415 volt rated voltage, 32 ampere rated current, rated frequency 50 hertz, coil voltage 415 volt. Auxiliary contact, it has 2 NO and 2 NC. So which are 2 NO? 2324 and 4344. These are the 2 NO contacts, and 1112 and 3132. These are the numbers given for the NC contact. So basically these NO NC are used for signaling purpose or buzzer purpose, isn't it? So this is how we have tested this. First contactor number 1, L&T make. Thank you.